Okay, we're going to look at piecewise functions here. My favorite way to look at a piecewise function is by graphing. So we're going to graph this function, and let's just review. If we take a rational function like x squared minus 1 over x minus 1, that's going to be the same as x plus 1 times x minus 1 over x minus 1, and it looks like right here we're going to have a whole at x equals 1. All right, so at x equals 1, somewhere I'm going to have a whole. So if I plug 1 into this function, 1 plus 1 is 2. So the whole is going to be right here. And the graph is x plus 1 other than that. So x plus 1 is going to be something like that. Okay, so now we're going to ask the question as to what is the limit as x approaches 1 of g of x. Okay, so I didn't quite finish graphing this piecewise function because this piece said I graphed the first half, and then it says at 1, it's 1, so it's going to be a point right there. Okay, so the graph comes up, has a hole, and has a point right there. So now the question is, what is the limit as x approaches 1 of g of x? Well, from the left, the intended height is 2. From the right, the intended height is 2. Okay? Now, if I were to ask you what g at 1 is, you would say g at 1 is 1. So you could say that these two are not equal to each other. Okay? All right, so now we're going to look at some properties of limits. These are very straightforward, and I think you'll find them pretty logical. So the first one we're going to look at, I'm going to give you an example and then we'll create the rule. We're going to look at the limit as x approaches 2 of 3. Okay, so here's my graph. 3 is going to be up here, 1, 2, 3, a horizontal line. Okay, and 2, as x approaches 2, what's the height the graph intends to reach? Well, that's 3. Okay, so it is 3. So the rule, what we can take away from this is when you take the limit of a constant like this, you're going to say the limit as x approaches c of k. It's always just going to be k. Okay, next page. Now we're going to look at something like the limit as x approaches 3 of x. Okay, so if we look at the graph, x goes like this. As x approaches 3, the height of the graph is also at 3. So this answer would be 3. So we're going to be able to say, here's a rule. This is a property. The rule is going to say the limit as x approaches c of x, it equals c. All right, just a couple more examples here. If you wanted to do a little substitution, so say you had something like the limit as x approaches c of x cubed plus 4x cubed minus 3, you're just going to substitute c right in there. So it's going to be c cubed minus 4c squared minus 3. That's a little substitution. Okay, you might have something like this, the limit as x approaches 2 of y to the 5th plus, or that's actually y to the 2nd, sorry, plus 5y plus 6 over y plus 2. And you're just going to do a substitution in this case. You're going to take 2 squared plus 2 times 5 is 10 plus 6, okay, over 2 plus 2, which is 4. So that's going to be 4. So you're going to end up with 20 over 4, which results in 5. So the limit as x approaches 2 of this is 5. If we were to graph it, we'd get the same answer. Okay. All right. Some other examples will come up in class, like what the limit of integer functions. I just want to remind you that int x is the greatest integer function, so that's your step function. So you're going to go and have step functions. It's going to look something like that. If you have questions about the integer function, just ask me in class, but that's what it's referring to when it says int x. Sometimes you'll see it written this way with an x with a bar, and that's the step function that they're referring to.